Okay, so picture this. A machine that can actually simulate the primordial birth of a universe.
Right, like calculating celestial trajectories and all that.
Exactly. It handles the chaotic emergence of microscopic life all in real time, and then it completely and catastrophically crashes when asked to process a tiny 300-word text document.
Which makes zero sense,
It
honest.
makes no sense. The screen goes black, these weird alien white bars tear across the monitor, and the whole system just dies.
Yeah, a total failure state.
So, welcome to the deep dive. For you, the learner who tunes in to bypass all those superficial summaries and get straight to the marrow of the subject, I mean, today is going to be incredibly special.
Oh, absolutely.
We aren't dissecting some polished corporate white paper today or a heavily edited keynote speech. Today's source material is raw. It's intensely personal.
And highly technical, yeah.
Very technical. It's a log entry written by an independent developer, and it's titled 5 Days Away. And our mission today is really to explore this profound dichotomy presented in the text,
Yeah, that brutal tension between world-changing tech ambitions and, well, the deeply frustrating reality of a physical world that just absolutely refuses to cooperate.
Refuses. I mean, what makes this specific log so compelling is the sheer density of it. Within a single 24-hour snapshot, the author layers biological realities, the digital friction of old hardware, network routing nightmares, and, a philosophical vision for an entirely new computing paradigm.
It's all in there. It completely strips away that myth of the frictionless, sterile laboratory where innovation supposedly happens, right?
Yeah.
And replaces it with the messy, chaotic reality of creation.
Okay, let's unpack this, because reading this log, it immediately subverts your expectations of what a technical document should even be.
It really does.
If you are designing a revolutionary computing substrate, you'd expect to open your daily log with a sprint update, or maybe a commit history.
Or a milestone chart. Yeah.
Right. But before we can even touch the author's massive technological universe, we have to start exactly where the author is forced to start. And that is with the biological baseline.
The wetware.
The wetware. The literal hardware of the human body. Because if that biological hardware isn't functioning, the software of the mind doesn't get to execute a single line of code.
So true. The log begins with this highly specific timestamp, right? 5:20 a.m., February 25th.
Early.
Very early. And the primary victory, like the actual win they lead with for the day, is simply not sweating through the night.
Which is such a raw thing to share in a devlog.
Yeah. The author notes that not waking up soaked, not having to roll over to find a dry patch of sheets, and not losing critical REM sleep is the foundational triumph of their day.
Wow.
They describe this sweating as something the body just does without asking. And that phrasing is so crucial. It isolates the autonomic nervous system as a rogue process.
A rogue process, exactly. That concept of the body doing things without asking is such a profound violation for someone whose entire life is built around deterministic control,
Right, because when you code, you dictate exact instructions.
Exactly. And if statement evaluates exactly as written. But the human body doesn't run on clean Boolean logic. It's this chaotic system of hormones and neurotransmitters.
Thermal regulation mechanisms.
Yeah, mechanisms that often operate in direct opposition to the conscious mind's goals. I look at this and see a direct parallel to thermal throttling in a CPU.
Oh, that's a great analogy.
Like when a processor gets too hot, the motherboard firmware forces it to downclock. It literally slows down the computational speed to prevent the silicon from melting. You can't just tell a thermal throttling CPU to run faster. The hardware interrupt overrides the software command.
It has to survive.
Right. So the author's body is essentially throwing a thermal interrupt, forcing a system restart in the middle of the night, and utterly destroying their cognitive processing power for the next day.
Yeah, that mechanism of the hardware interrupt is the perfect lens for this. Night sweats, physiologically, are often driven by a spike in sympathetic nervous system activity.
The fight-or-flight response.
Exactly. You're a fight or flight kicking in when you should be in a parasympathetic restorative state.
Yeah.
And the author notes they're trying to debug this biological hardware issue by introducing a specific chemical patch, magnesium.
Testing a patch on themselves.
Yeah. They write, the magnesium might be working. We don't know yet. Time will tell. Magnesium functions essentially as a biological dampener. It binds to GABA receptors, which calm nerve activity, and blocks NMDA receptors.
Preventing excess signals.
Right. They're applying the scientific method, introducing a variable, controlling the environment, and waiting for the morning logs to see if the thermal interrupt fires again.
But I look at this opening and I have to ask, why include it? Why document the magnesium protocol right next to the architecture of a global network?
It's unusual.
Very. For a lot of technologists, the body is treated as an annoyance, something you just try to ignore with caffeine and ergonomic chairs until it forcibly shuts you down.
Which it eventually will.
Right. So documenting this feels like they are recognizing the human body as node zero in their network topology. If node zero fails, the entire routing table collapses.
They're acknowledging the absolute limits of abstraction here. I mean, in the massive tech corporation, the individual biological unit is entirely abstracted.
Right. If someone gets sick, another dev takes over.
Exactly. If a developer goes down with a fever, the ticket is reassigned, the integration pipeline keeps running, the servers stay lit. But for the solitary creator, there is no abstraction.
They're a single point of failure.
They are. By documenting the sweat and the magnesium, the author asserts that the biochemical state of their nervous system is functionally inseparable from the physics engine they are coding. It's one unified, fragile ecosystem.
And here's where it gets really interesting, because once they establish that node zero, the biological body, has successfully booted up without a thermal crash, they pivot to node one, the digital body.
Ah, yes, the old PC.
They write, the rest of the day was computers. But this isn't a smooth transition into high-performance flow state. We're introduced to the old PC, which they explicitly describe as a low-end gaming rig.
A very tired machine.
Yeah, but the history of this specific machine is staggering. The author has achieved things on this underpowered silicon that sound like pure science fiction.
The author details creating a custom 2D physics engine on this machine. And they emphasize it wasn't just a static rendering, it produced actual emergent behavior.
Emergent behavior, yeah.
They simulated stellar objects and what they call a primordial protein soup. The key term for the learner here is emergence. In computational physics, emergence occurs when you program very simple, localized rules.
Like basic gravitational attraction.
Right, or electrostatic repulsion between particles. And from those simple rules, incredibly complex, unpredictable, macroscopic patterns arise.
It's like Conway's Game of Life, right? Where 3 simple rules about neighboring pixels can generate these infinite, evolving fractal patterns that look like actual biological reproduction.
Precisely. They engineered a system where particles interacted in a way that never quite reached a static state. It was constantly calculating, resolving micro-collisions, mathematically sustaining a dynamic equilibrium.
Which is mind-blowing for an old PC.
It really is. To achieve that on a low-end gaming PC requires incredibly optimized bare metal programming. It requires writing code that speaks directly to the processor's floating point unit with zero wasted overhead. The author essentially says they made the universe on this machine.
They played God with a cheap GPU.
Yeah, they coaxed chaotic, generative beauty out of aging hardware.
It's an immense triumph of human intellect over material constraint, which makes the subsequent failure so jarring it almost feels like a punchline.
Oh, the Google Docs crash?
Yes, this exact same machine, which successfully calculated the emergent mechanics of a primordial universe, cannot run Google Docs.
Not even a little bit.
And I don't mean it runs it slowly. The author specifies that opening just the application or a tiny 300-word one-page file causes catastrophic system failure.
Just 300 words.
300. The mouse jumps. Clicks take multiple seconds to register. The CPU spikes to 50% capacity just trying to render a few paragraphs of text.
This juxtaposition points to a profound crisis in modern software architecture, honestly. The catastrophic cost of abstraction. When the author coded their physics engine, they were operating with extreme memory efficiency, managing every byte.
Every single cycle counted.
But a modern cloud-based application like Google Docs is an entirely different beast. You're not running a simple text editor. You're running a massive, asynchronous, single-threaded JavaScript engine nested inside a browser, which is practically an operating system itself.
Right, because when you type a single character into Google Docs, you aren't just flipping pixels on a screen.
No, not at all.
That single keystroke has to be captured by a browser event listener, parsed by JavaScript, injected into a massively complex document object model, and then immediately serialized and sent over a WebSocket connection to a server in Virginia or Oregon to achieve real-time synchronization.
All for one keystroke.
And it's doing this while running spelling algorithms, formatting checks, and analytics trackers simultaneously.
And this is where the hardware bottleneck of the old PC reveals itself. That low-end gaming PC might have an older GPU capable of parallel processing for a custom physics engine, but its CPU likely suffers from terrible single-core performance.
And JavaScript hates that.
JavaScript fundamentally operates on a single main thread. It cannot easily distribute that massive overhead of DOM manipulation and WebSocket pinging across multiple cores.
Ugh.
So a 300-word document forces the aging CPU core to pipeline thousands of abstracted operations just to render the letter A.
Unbelievable.
The CPU spikes to 50% because a single core is completely redlining, just choking on the bloat of modern web architecture.
I feel like we're looking at an eccentric mathematical genius who can effortlessly compute orbital mechanics in their head, but if you ask them to fill out a tax form using a bureaucratic portal, they literally faint.
That is exactly what's happening.
But the failure isn't just a laggy mouse. The log describes a total crash, and the imagery is haunting. They write, black screen, white bars going across it in a pattern that didn't even look like static, just something we'd never seen a computer do before.
Yeah, that's not your standard blue screen.
Not at all. It's not the standard Windows glue screen of death. It's an alien failure state.
A crash of that visual nature, a black screen with geometric, non-static white bars. It suggests a total collapse at the hardware-software boundary.
Like the GPU just gave up.
Basically. It implies the CPU bottleneck became so severe that it failed to send the necessary keep-alive signals to the GPU, or maybe a catastrophic memory leak in the browser engine caused a VRAM segmentation fault. The graphics card essentially panicked, dumping raw, unformatted memory contents onto the display controller.
It lost its mind.
The machine didn't just freeze, it lost the ability to comprehend its own display protocols.
And the author's conclusion to this absolute obliteration of their workstation, Google is currently winning.
Yeah, that line is heavy.
It's so loaded. It's not just a complaint about a buggy app. It is a philosophical concession. They built the universe on their own terms, but the inescapable gravity of standardized corporate software destroyed their environment. The bloat defeated the elegance.
Which forces a massive, agonizing pivot in the log. Because the old PC is now completely failing as a primary workstation for writing, the author must split their digital ecosystem.
They have to adapt.
Right. They decide to strip the old PC of its primary duties and repurpose it to run quietly in the background, making way for a future, heavily delayed new build. And this introduces us to the next layer of friction, the creation of the headless server.
Headless, it's such a visceral term.
It really is.
For the learner who might not have spent time racking servers, a headless machine is a computer operating entirely without physical interfaces. No monitor, no keyboard, no mouse. It is essentially blind and deaf to the physical room it sits in.
Just a humming box in the corner.
Exactly. It connects only to the network, processing data in the dark. And the author wants to use this crashing, temperamental old PC to handle their home automation and, crucially, a Minecraft server for someone they call their star sister.
The intention here is deeply functional, but also highly emotional, you know? Amidst all this dense technical friction, the end goal is to maintain a persistent digital space for interpersonal connection.
Which is beautiful, really.
But achieving that headless state requires navigating the labyrinth of network protocols, which are notoriously opaque and unforgiving.
Oh, don't I know it.
The author details spending agonizing hours fighting with SSH connections, virtual machines that refuse to ping each other, and the absolute nightmare of local versus global IP addresses.
The IP address struggle is such a classic, maddening hurdle. I want to drill into this because it illustrates the invisible walls we build into our networks.
Yeah.
The author can see the server on their local network. They know the machine is alive. But from the outside world, it just doesn't exist. Why is crossing that boundary from the local router to the global internet so consistently broken for independent developers?
Well, it comes down to IPv4 exhaustion and the architecture of NAT, network address translation. Because we ran out of public IP addresses decades ago, your home router acts as a massive gatekeeper.
It's holding the keys.
Yeah, it holds the one public IP address assigned by your ISP, and it creates a private, fake network inside your house. When the author tries to expose the Minecraft server, they aren't just opening a door. They have to explicitly program the router to take packets arriving from the global internet on a specific port and translate them, blindfolded, to the specific internal IP of that old PC.
And so many things can go wrong there.
So many. If the router's NAT table drops the rule, or if the ISP employs carrier-grade NAT, or if the virtual machine's bridge network adapter fails to inherit the correct subnet mask, the packets just silently drop into the void. There is no error message.
The ping just times out.
Just times out.
The silent failure. That is the true torture of networking. And that torture compounds when the author moves to software deployment. They mention their smart home interface, Home Assistant, loading as a completely blank screen, just void.
Infuriating.
And then they attempt to download a Docker image, and it gets stuck for exactly 23 minutes. I
Mhm.
read that, and my blood pressure spiked.
Same. 23 minutes is a lifetime in computing.
23 minutes of absolute frozen purgatory. For our listeners who build software, a Docker image pull hanging is uniquely psychological torture. What is actually happening under the hood during a silent 23-minute hang?
Well, Docker relies on a union file system. When you pull an image, you aren't downloading one file. You're downloading dozens of compressed cryptographic layers that have to be downloaded, verified, and extracted sequentially to build a container's environment.
So it's a very delicate process.
It's extremely. A 23-minute hang usually points to a stateful protocol failure. Perhaps the TCP socket connection to the Docker registry dropped a packet, but the registry server didn't send a reset packet back.
So the machine is just waiting.
The author's machine is sitting in a fin-wait state, politely waiting for a network acknowledgement that is never coming. It refuses to time out because the default keep-alive parameters are too generous, and it refuses to move forward. The machine isn't thinking. It's just stuck in a dead-end state machine loop.
It's paralyzed, and it paralyzes the creator with it. You don't want to cancel it because what if it's just extracting a really large layer?
Right, you don't want to break it.
What if you interrupt it and corrupt the local cache, so you just stare at a frozen progress bar? But the resolution to this entire nightmare, the routing failures, the blank screens, the Docker hangs, it is the most authentic IT moment I have ever read.
Oh, I love this part.
The author types a command that they admit probably had nothing to do with it, and the system miraculously fixes itself and spins up.
The dark magic of stateful computing. Modern computing environments have so many interdependent cached states. DNS caches, ARP tables, memory page files. Sometimes executing an unrelated command causes a cache flush or a background daemon restart that unintentionally clears the invisible bottleneck.
Just a random digital hiccup clears the pipe.
Exactly. It reinforces the author's underlying frustration. They are trying to build deterministic systems on top of infrastructure that behaves unpredictably.
But out of that chaos comes a climax of profound control. The author is exhausted. They step away from the physical machine. They pull out their phone, open a terminal app, connect via SSH, paste the startup command into a tiny text interface, and watch the Minecraft server successfully load.
It's an incredible visual.
They control the entire virtual infrastructure without physically touching the machine. They write, "It was genuinely a good moment." There's something so poetic about taking this massive, crashing visual failure, the white alien bars of Google Docs, and reducing it down to pure, silent command line text executing from a pocket screen.
It is a moment of sensory and technical reclamation. By rendering the server headless, they stripped away the bloated GUI, the DOM rendering, the crashing graphics driver.
How's noise?
They bypassed the physical constraints of the keyboard and monitor. Through the SSH terminal, they are interacting with a machine at its most fundamental linguistic level. It is pure instruction.
Just text.
Just text. They have taken a system that was wildly out of control and placed it inside a dark box where it can only speak when spoken to via a cryptographic key. They regain their agency.
Which brings us to the ultimate burning question of this entire log. We've watched the author battle their own autonomic nervous system, we watched a massive CPU spike over a text document, and we endured a 23-minute invisible network hang. Why?
Yeah, why do this to yourself?
Why subject yourself to this grinder of daily frustration? The log shifts gears radically right here. The localized, petty squabbles with hardware melt away, and we realize these are merely the frictional stepping stones toward an incredibly vast, almost utopian technological vision.
The transition in the text is stark. The author writes, "The thing that stays with us, though, is this. We understand exactly what we're building and why. We can see the whole shape of it."
Gives you chills.
It really does. This is a statement of profound architectural clarity. They are not merely debugging a home server to play games. They are prototyping the foundation for something monumental. They outline the components of this vision: a Lattice network, an orbital computing substrate, and an application suite.
Orbital computing substrate. The phrase alone is massive. It sounds like a Dyson sphere for data.
It really does sound sci-fi.
For a listener versed in network topology, what does an orbital computing substrate built on a lattice network actually imply mechanically? How does it differ from the internet we are using right now?
Well, the current internet, despite its decentralized origins, has become highly centralized at the application and infrastructure layers. You connect to an ISP, which routes your traffic through massive data centers owned by hyperscalers, AWS, Google Cloud, Azure.
Right, a few big players on the pipes.
Exactly. It is a hub-and-spoke model. A lattice network implies a true peer-to-peer mesh topology. In graph theory, a lattice ensures that every node is connected to multiple adjacent nodes, creating highly redundant, non-hierarchical routing paths. If one node fails, the data simply routes around it.
So there is no central server farm to bomb or to unplug or to subpoena.
Precisely. And the orbital computing substrate suggests taking that lattice and abstracting it into a ubiquitous layer of computational power that envelops the globe.
Wow.
Instead of sending your data to a server in Virginia to be processed, the processing power is distributed across the idle capacity of every device on the lattice. Your phone, your neighbor's smart fridge, the author's headless server, they all become micronodes contributing CPU cycles and storage to the substrate. It's edge computing pushed to its absolute theoretical limit.
And the author makes the ideological stance of this architecture abundantly clear. They describe it as a decentralized system that doesn't belong to any billionaire, something that any phone can hold a piece of.
It's very anti-monopoly.
Highly. This is the counterpunch to their earlier statement that Google is currently winning. They aren't trying to build a lighter text editor to compete with Google Docs. They are trying to functionally obsolete the entire paradigm of corporate-owned, centralized computing. They want to tear down the hyperscalers and distribute the power to the literal pockets of the users.
What is remarkable is that the author does not present this as a mere manifesto. They ground this utopian vision directly in the gritty technical reality we just discussed. They write, the math exists, the physics engine worked, the coherence is there.
They've already proven it to themselves.
Exactly. This is the vital connection. That primordial protein soup they coded on the old PC. That wasn't just a toy, it was a proof of concept. They proved to themselves that they could generate complex, emergent coherence from basic, decentralized mathematical rules on cheap, consumer-grade hardware.
They're scaling the physics engine. If they can make a universe emerge from a single motherboard, they believe they can make a new internet emerge from a global web of interconnected phones.
That's the dream.
But I have to throw a flag here. I have to push back. I want you to think about this, and I want the learner to really analyze this juxtaposition. The author just spent hours agonizing over a local IP address and staring blankly at a frozen Docker image.
Fighting with NAT rules, yeah.
The friction of basic networking almost broke them. Is it not the height of hubris to think you can build an orbital computing substrate that overthrows billionaire tech monopolies when you can barely get Home Assistant to load?
It appears contradictory, I hear you, but historically, this is the exact psychological and environmental profile of paradigm-shifting engineering. Grand visions do not emerge from frictionless environments. They emerge from a deep, intimate understanding of the system's current flaws.
I see what you mean.
The Wright brothers didn't invent powered flight by conceptualizing aerodynamics in a vacuum. They figured it out while dealing with the grease, the snap chains, and the friction of building bicycles. The author's struggle with Docker and NAT traversal isn't evidence of incompetence. It's evidence that they are in the trenches, feeling the jagged edges of the current protocols.
And the ideation process for the substrate proves how deeply it's integrated into their psyche. They don't say they brainstormed this in a boardroom. They write that this vision was refined in these logs, in therapy, in the half-awake hours between rolling over at 3 a.m.
That mention of therapy is profoundly important. It indicates that the author views the technological problem as fundamentally intertwined with the human condition.
You can't separate the two.
Right. You cannot design a network intended to empower human agency and resist corporate manipulation without understanding the psychological vulnerabilities of the human nodes it serves. They are debugging their own psychological trauma and cognitive biases alongside their codebase. The fact that the lattice network's architecture is being forged in therapy and in the vulnerable, sleep-deprived hours of 3 a.m. demonstrates that this isn't just a project. It is an all-consuming alignment of their personal ethos and their technical capability.
So what does this all mean? We have an author who has secured their biological baseline, repurposed their failing hardware into a headless workhorse, and crystallized the mathematics for a revolutionary, decentralized internet. They are standing on the precipice of tomorrow. They are ready to write the code that changes the world.
But then...
And then the log brutally snaps us right back to the most mundane, unyielding reality imaginable.
The hard limit of the physical world. The entire grand vision, the new PC build that is required to actually compile and run this world-changing code, is entirely halted. They are waiting, as the title of the log dictates, 5 days away for a single power adapter.
A power adapter. A rudimentary box of copper coils, a transformer, and some plastic wiring designed to convert alternating wall current into direct current. You can conceptualize a cryptographic lattice network that spans the globe, but if you cannot physically bridge the gap between the wall socket and your motherboard, you are absolutely powerless.
It is the ultimate bottleneck. In the OSI model of networking, layer 1 is the physical layer. The actual cables, the voltages, the physical reality of the connection.
We always forget about layer 1.
We do. We spend so much time obsessing over layer 7, the application layer, the grand visions of substrates and metaverses, that we forget that all of it is utterly dependent on the brute force reality of layer 1. The author is trapped at layer 1.
And it's not just a single missing cable holding them back. The author lists the surrounding context of their life, and it is a cascading litany of chaotic, entirely physical constraints that are acting as heavy anchors on this brilliant mind.
The world outside the computer.
Yeah. They write, the weather has been the worst in 50 years. We haven't been to the bank. We haven't been to the food bank.
That line hits hard.
Let's pause and absorb that. We haven't been to the food bank. The person designing an orbital computing substrate to democratize the internet is experiencing food insecurity. They are relying on a local food bank to maintain caloric intakes, and a 50-year storm is physically preventing them from getting there.
This completely shatters the Silicon Valley myth, doesn't it? The
Yeah.
myth of the fully funded, frictionless innovator who can simply order food delivery and focus purely on the code.
Exactly.
The cognitive load of survival is directly competing with the cognitive load of creation. The constraints they list are systemic and deeply human. A tattoo design has been pending for 3/4 of a year because the artist hasn't been seen. The Star Sister, the emotional anchor for the headless server, is quiet, suggesting interpersonal distance or worry. A doctor failed to run a medical test properly, introducing bureaucratic healthcare friction.
Supply chain logistics delaying the adapter. Extreme weather halting movement. Economic hardship forcing reliance on food banks. Medical errors leaving health questions unanswered. The vulnerability of the visionary is staggering here.
It's all so fragile.
The entire future of this anti-billionaire internet rests on whether a delivery truck can safely navigate a 50-year storm in 5 days, and whether the creator can secure enough calories to keep their biological hardware from throwing another interrupt. The digital universe is entirely, terrifyingly contingent upon the stability of the physical one.
And, as the ultimate irony, they close this litany of disaster by reiterating, and Google Docs crashed our computer twice.
It's the perfect comedic beat in a tragic symphony. I mean, you can't write that.
Okay.
But despite this crushing weight of physical and digital reality, the author doesn't end the log in despair. They do something remarkably resilient.
They look at what they can control.
Yes. They take an inventory of the microscopic domain they actually managed to control today.
They compartmentalize the chaos. The final lines read, but the magnesium might be working. The server is running. The Minecraft startup command is saved on the phone. 5 days.
They locked in their wins.
Exactly. They have locked in their victories. The biological baseline is patched. The sweat has stopped. The back-end infrastructure is secured. The headless server is alive in the dark. And the digital key, the command on the phone, is ready to deploy. They have executed every possible operation within their immediate sphere of influence. Now, the only variable left is time.
5 days. It's a countdown. It's a testament to the endurance required to create anything of value. As we wrap up this deep dive, The Learner, I want you to step back and look at the sheer distance we've traveled in this single 24-hour log.
It's been a journey.
We started with the intimate biochemistry of a dry night of sleep, manipulating NMDA receptors with magnesium to prevent a biological kernel panic. We moved into the wild paradox of a GPU rendering the chaotic beauty of a primordial universe, only to have its CPU choked to death by the abstracted bloat of a 300-word Google Doc.
We dissected the agonizing silent 23-minute hang of a Docker container and the psychological reclamation of stripping a machine to a headless state controlled entirely by pure text over an SSH tunnel.
And then the big vision.
Right. We explored the mathematical coherence of a decentralized orbital computing substrate designed to route around billionaire monopolies. And finally, we crashed violently back down to Earth, trapped by a 50-year storm, reliant on a food bank, and waiting 5 agonizing days for a physical power adapter.
It is a breathtaking, unvarnished portrait of what it actually means to build the future. And I want to turn this directly to you. Think about the projects you were trying to push forward. What is your power adapter?
What's holding you back?
Right. What is the small, mundane, deeply frustrating physical or logistical limitation that is currently standing between you and the execution of your own grand vision? Is it a delayed permit, a piece of legacy software that refuses to compile, a physical space you haven't been able to secure? We all have our 5-day waits. The friction is a feature, not a bug.
And while you are waiting, it is worth analyzing the nature of the systems we tolerate daily. We demand seamless, frictionless experiences from our bloated applications, but as this log proves, true innovation, the kind that requires emergent math and deep psychological alignment, rarely survives contact with those rigid, generalized systems.
Which leaves us with one final, lingering thought to mull over. If an old, failing, low-end gaming PC can successfully calculate and sustain the chaotic, emergent, unpredictable beauty of a universe in motion, but completely shatters and panics when it's asked to process a rigid corporate text document, well, maybe the universe wasn't meant to be organized into a Google Doc.
I think you're onto something there.
Maybe true creation is inherently messy, it requires bare metal focus, it crashes often, and sometimes the only way forward is to just wait out the storm.
A profound thought to end on.
Thanks for taking the deep dive with us. We'll be here, waiting out the storm. Until next time.